So just by setting up this canvas, I've realised how hungry I am. I haven't had my lunch yet, and putting these pictures in, I could tuck right into that those lentils. Let's talk about diet. Now, the first thing I want to do, and we'll relate it to these images in a moment, I want to talk about the functions of nutrients, okay? The functions of nutrients. And we're going to look at a handful, and we could extrapolate this a bit further and talk about others, but we're going to focus in on a handful here, okay? So the first nutrients I want to talk to you about is I want to talk about carbs or carbohydrates. And I'd hazard a guess that you're studying these things extensively in biology, and you know your starch tests from your sugar tests and various other bits and your carbohydrates and blah, blah, blah. But the key thing I want you to be aware of here is that carbohydrates are energy. I cannot stress that enough. They are ultimately converted once we eat them into simple sugars. And it's simple sugars that we can utilize for things like respiration. And a great example of a simple sugar is glucose. So a lot of the focus of sort of energy-based nutrition carbohydrates is, can we get carbohydrates in so we can convert them to glucose and then use them in processes such as respiration? And I think a great example of these would be, think about your potatoes, think about things like rice, think about things like pasta. We also have carbohydrates in lots of vegetable products as well, in certain cereals as well. Think about flour. I mean, we've mentioned here pasta, for example. Pasta's obviously typically derived from wheat flour. Now, flour it is a carbohydrate-rich structure. It actually has some interesting proteins as well, but it's a carbohydrate-rich structure. Now, I just want to mention with glucose, if I take our glucose concept that I mentioned a moment ago, when we consume our carbohydrates, of course we can use glucose for energy, for respiration, for other cell processes, but we can also store it. And we can store it in places like the muscle as glycogen. Okay, so there's a nice word for you to learn. But as I've said already, it can also go to cellular function. And the one we really need to pay attention to is respiration. Okay, so that's really the use of that glucose. Good stuff. Let's move this on. I want to talk to you about fats, or as you're probably referring to in your biology studies as lipids. Okay, I'm going to refer to them fats here, but come on, let's treat ourselves and put the old lipids word in here too. Okay, so we're talking about lipids here. And can I stress again that lipids are a form of energy? Okay, a form of energy, but they also perform the role of insulation. Okay, so insulation also, so energy and insulation. And we derive fats basically from vegetable sources, plant sources, and animal sources. So examples would be things like meat, dairy, fish. I could keep going here. Nuts, pulses. Let me put nuts in. Fish, nuts. Okay, and of course we get different fats from different things. Now remember that some fats are very, very positive for us. We would anticipate our diet being around about 25% fats, for example. But the point we need to make is this one. If we consume fats and they are unused, well, what happens to them? They get stored as fat. And that fat gets stored under the skin. Okay, and you know, that is what we call subcutaneous fat. I'm not going to write it down. But that under the skin fat, it can lead to things like obesity. Now, be clear, that's over a long period of time. It's not like you're going to eat one hamburger and be obese. That's not how that works. But, you know, if we are eating these twice a day for 10 years, it might happen. Okay? So that's something we want to be aware of. Let's keep this going. Let's just loop over here. I want to talk to you about proteins. Now, again, this is a substrate that you are aware of. It's insoluble. You know this from your biology studies, but it is made up of amino acids. Okay, so it's really important. And the objective of consuming and processing proteins is actually to break the amino acids down into singular units, and then we can build other proteins. I mean, you guys know a bit about that. But the important thing is that they are involved in repair and they are involved in growth. So consider how important proteins are to an athlete, because it repairs damaged muscle tissue. It leads to adaptation process because it allows sort of, let's say, muscular growth, or even the building of things like bone cells, for example. I mean, this is all important stuff. And again, we get this from meat. We get it from fish. We get it from nuts. I should have set up here, by the way, with our fats. I mean, don't forget, obviously, I mean, I'm talking about meat, dairy, fish, and nuts. I mean, we're talking about oils in there, aren't we? We're talking about, we're talking about animal-based things. It could be sort of lard-based, for example. But anyway, let's move on from there. And finally, guys, on this particular section, I want to talk to you about water. okay, and the consumption of water or fluids, okay. And the key thing is that water promotes hydration and prevents dehydration. Of course, that's really important for what? For cell function. And again, we're not going to get into osmosis here. You guys can probably tell me all about it, but of course we need to make sure that our cells are well hydrated for effective cell function. So that's really important. Now, I want to talk to you about an important concept, and it is this one. It is what we refer to, if I choose a colour, it's what we refer to as energy balance. And there's a couple of points I want to make here. Energy balance, okay? Energy balance. So first thing, I want to just look at how much energy people kind of need. So let's look at adult men for a start off. Men typically will require something in the region of 2,500 kilocalories per day. Okay, so before we sort of decide whether that's a lot or not, let's just make sure we can compare it. If we looked at, on average, adult women, how much they need, typically they're at about 2,000 kilocalories a day. So the first thing we're saying is, on average, with lots of exceptions because people are different, men will typically consume more calories. Calories are a unit of heat or energy, by the way, I'm not going to get into it here. And men are going to consume a little bit more. Now, let's have a think about teenagers. So by teenagers, by the way, I'm going to refer to teenagers as boys and girls. I basically couldn't think of a better way of putting teenage boys, how do you say that? Teenage juveniles. So what's the word I would use? But you know what I mean. So I'm looking at boys here in sort of teenagers, maybe kind of the people watching this tutorial kind of age maybe. And we're going to say here that boys are going to take on board in the region of 2,200 kilocalories. And that is a day, remember? And let's just refer to girls as girls. And girls, on average, are going to be consuming something like 1,800. That's annoying, isn't it, girls? Kilocalories a day. Okay, so just be aware of those sort of differences. But really, where I want to finish this tutorial off, I mean, that's all well and good saying how much different groups should take on. But this is the key thing. I want to talk to you about what promotes stable weight. And that's nothing to do with horse racing, by the way. What promotes weight gain, okay, and what promotes weight loss, okay. And I wonder if you can just figure out what it is that I'm going to write down here. So for stable weight, what we'd expect is the following equation. Energy in is equal to, guess what, energy out. Okay, so if we've got an individual who over a period of time, doesn't need to be in one day, but over a period of time, the amount of energy they've taken in food and fluids is the same as the amount of energy they spend through metabolic activity and movement, then of course that's going to mean stable weight. Well, what would be the relationship here? Well, what we're saying here is that energy in, let's just write energy out over here. I mean, you decide which symbol I should write in this gap here. What should that look like? And we're saying that to gain weight, so if energy in is bigger than energy out, then an individual is going to gain weight over time. And then finally, guys, if we go for sometimes my pen, energy in and energy out, guess what we're going to put here? If energy out is bigger than energy in, this could be, for example, someone who's dieting, someone who's become very active for a period of time, for example, someone who started cycling to work rather than driving to work, all of a sudden they might find their energy expenditure is greater than what they're consuming. And what happens? They get thinner. Okay, now, can I stress to you that of the three groups here, this is the healthiest. Okay, now we all know that this over extended period of time is not good, but also bear in mind that this over extended period of time is not good. This is the one that people should be aiming for over a period of time. It does not mean that you consume the exact calories on every single day, 7 days a week that you spend, but over a period of time, over your cycle, over your life, that should be how it works. Cheers.